What is amplitude shift keying, or ASK?
Amplitude shift keying, or ASK, is a digital modulation technique used to transmit information. Here's how it works. A carrier wave, think of it as a high-frequency sine wave, is used as the base. To transmit data, the amplitude of this wave is adjusted. For example, a higher amplitude represents a binary 1, and a lower or 0 amplitude represents a binary 0. This simple technique effectively translates digital data into a form that can travel across communication channels. ASK is widely used in technologies like optical fiber communication and RFID tags due to its straightforward design. But there's a catch. ASK is sensitive to noise, which can impact signal reliability in noisy environments.
How ASK works? Amplitude shift keying, or ASK, is a simple yet fundamental concept in digital communication. Let's break it into easy steps. First, we start with a high-frequency sine wave called the carrier wave. This wave acts as the foundation for carrying information.
Next, we introduce the digital data we want to transmit, binary bits, such as ones and zeros. Here's where amplitude modulation comes into play. The carrier wave's amplitude is adjusted based on the binary data. For example, if the input is 1010, the carrier wave alternates between high amplitude 4-1 and low or no amplitude 4-0. This modulated signal can now be transmitted through a communication channel, carrying the binary information. ASK signal waveform. Figure represents a message signal represented in the forms of the bit stream. Shows the carrier wave, whose amplitude is to be varied according to the digital message signal. Shows the resultant ASK waveform, which is amplitude modulated. It is clear from the figure that the signal is present only in case of the high-level digital stream. No signal waveform is achieved when the bit shows a low level, showing on and off behavior. Advantages of ASK.
Simplicity in design and implementation. ASK is one of the simplest modulation schemes, making it easy to design and implement. Example, in a low-cost wireless communication system, ASK can be used because of its straightforward circuitry requirements. Energy efficiency. During the transmission of binary 0, no carrier signal is transmitted, depending on implementation, saving energy. Example, in RFID systems, energy-efficient communication is achieved by sending ASK signals only when data is present.
Efficient for low-bandwidth applications. ASK works well in systems where bandwidth is limited and the data rate is low. Example, remote control devices such as car key fobs often use ASK because they require low data rates over short distances.
Disadvantages of ASK. Susceptibility to noise. ASK signals are highly affected by noise, especially in environments with varying amplitude interference. Example, in wireless communication, external factors like weather or electrical interference can distort the signal. Signal loss at low amplitude. Low signal amplitude, representing binary 0, may lead to data loss in the presence of weak signals. Example, in long-distance communication, weaker ASK signals can result in higher error rates. Lower data transmission rates. ASK is less efficient for high-speed communication, as it cannot transmit data as quickly as other modulation methods like frequency shift keying, FSK, or phase shift keying, PSK. Example, ASK is unsuitable for high-speed internet or modern wireless technologies. Application about ASK.
Applications of ASK. Low-frequency RF applications, tire pressuring monitoring systems, home automation devices, wireless base stations, use in satellite links. Formula of ASK. General equation of ASK, where VASK, T, equals amplitude shift keying, VM, T, equals digital information signal, A2 equals unmodulated carrier amplitude, omega C equals analog carrier radian frequency for digital information signal, if VM, T, equals +1 for binary and VM, T, equals 1 for binary 0 then. Conclusion of ASK.
ASK is a simple and cost-effective modulation technique where the carrier signal's amplitude varies with the binary message. It is easy to implement but prone to noise, making it suitable for short-distance, low-budget, or low-speed applications like optical communication and RFID systems.
Thank you.